So we are trying to prove that this thing here is a cyclic quadrilateral. And then for us to prove that this thing here is a cyclic quadrilateral, as I said, these are the things that I can prove. If I can prove that A1 is equaling to O2, this thing will be a cyclic quad. And then I will say that I have angles in the same segment. Or I can prove that S1 is equaling to B1. And then it will also be angles in the same segment. Or I can prove it using O1 is equaling to this whole thing here. Because both of them will be created by AS. They will be subtended by this chord AS if there was a circle, but the circle is not there as yet. So these are the things that I'm going to try to prove. If I can do that, then this thing here will be a cyclic quadrilateral. Now, how am I going to do that? Look at the following here. I want you to tell me something about this angle here. This angle here is at center. Can you see that?
Yes.
Yes. So we have an angle at center. Now, I just want you to tell me who's creating this angle at center here. Who's subtending this angle at center? Let me put it that way. The angle at center is subtended by whom?
O1 is subtended.
Yes.
By A and S. Or
let's look at,
A and R.
They're subtended by?
AR.
AR, ne? So they're subtended by this chord, yes. This arc AR. Yeah, they can be subtended inside the circle. Okay, they're subtended by this chord AR. Okay. Now let's check here. Is there any other angle which is subtended by AR? So this one here is at the center. Okay? Yeah. Is there any other angle subtended by AR?
Is B2 plus, no, just B2.
Just B2.
Yes.
So if, look at the following here. I'm using the blue color. So this one is subtended by AR. This one is subtended by AR. This one here, you're saying it's also subtended by AR. Ne? Now, this one and this one, they are both subtended by AR. It means which they have something in common. The only difference between them is that the other one is at the center, the other one is at the circumference. Can you see that one again?
Yes.
What do you know about angles subtended by the same arc? And then one is at the center, one is at the circumference. What can you tell me about those two?
Each angle at center becomes angle at the circumference.
So O1 is going to be equaling to 2 times B2 again. And then the reason that you're going to use here is that we have angle at center is going to be equaling to 2 times angle at circumference.
Yes.
Yes. Okay. Now we know what is B2. Look at what they told us. What is B2?
X.
It's X. Ne? So it means O1 is going to be equaling to 2X. Instead of B2, we're going to write what? 2X. Okay?
Yes.
Okay. But now look at this again here. B1 and B2 and B3. What is B2 and B3?
X.
B2, it's X again. B3 is what? It's X. No?
X.
So what is going to be X plus X?
2X.
It's 2X again. Now look at this one here. One of the things that I wanted to prove that O1 it should be equaling to B2 plus B3. And then if you can check that, what is B2 plus B3 here?
It's 2X.
It's 2X again. What is O1?
Yes.
What is O1?
2X.
2X. So it means that I've proven one of the things that I was required to prove here. So it means this thing here is a cyclic quadrilateral. So I can write it this way now. Look at the following. I am going to say we started by saying this one here, it's angle at center. So we said this one is going to be 2 times B2 because we have angle at center. And then we'll tell them which, okay, B2 plus B3 is going to be equaling to X plus X, which is given this one. We can tell them with this one here, it's given. And then we'll say that we have B2 plus B3, which is going to be equaling to 2X. Now, therefore, it means O1 is going to be equaling to B2 plus B3. And then the reason that I'm going to tell them is that both are equaling to 2X. Again.
Yes.
Therefore, I am going to tell them that OASB is a cyclic quadrilateral. How did we prove our cyclic quadrilateral here? Which method did we use to prove our cyclic quadrilateral? So this angle here is equivalent to this one. So this one here is 2x. And then this whole thing here is equivalent to 2x. How did we prove our cyclic quadrilateral? Here we are going to use this one that says converse angles in the same segment. So we'll take that one. It says we have converse angles in same seg. Are you still good, Ben?
Yes.
Okay. Now, the next one, when we go to the next one, even if we couldn't prove which this thing here, it's a cyclic quad. That's what you should know about this question. Even if we couldn't prove this one, when you go to the next question, just put a circle around this thing. It's a cyclic quad now. Meaning that AS is a chord. It means that AS is a chord, SB is a chord, OB is a chord, and then AO is a chord. Meaning by now, S1 is equaling to B1. These two are equal now. Are you good?
Mm.
And then it also means that O2.
Yeah. Why are they equal?
They're equal because this thing here is a cyclic quadrilateral. Again, remember here, we're trying to prove which this thing here is a cyclic quad. Ne? So I'm saying, in an examination, if they give you to say, prove this thing here, it's a cyclic quadrilateral. Let's say you were not able to see this part here, the part that I just showed you here. You couldn't prove with this thing here, it's a cyclic quad. When you go to the next question, even if you couldn't prove this one, when you go to the next question, this thing here, it's a cyclic quad. So what you have to do is just to draw a circle around this thing here, and then it is a cyclic quad once you go to the next question.
Okay.
Does it make sense?
Yes.
Okay, so now we have a cyclic, we do have a cyclic quadrilateral. It means now you can definitely draw a circle around this thing, and then everything which was not a chord before, now it is a chord. Like for example, AS was not a chord of this circle here, of this bigger circle here, it was not, but it is a chord of this red circle that we've just drawn. Although it doesn't look like a circle, but you just have to have a rough sketch of a circle. So now we are trying to prove that this here, this angle here is going to be equivalent to this angle here. That's what we are trying to do now. We want to prove that this one here is going to be equivalent to this one. Then, Ben, okay. We'll say then, look at the following then. We are trying to prove that this thing here is equivalent to this one again.
Yes.
Yeah. So one thing that we already know is this one. We know that S1 is equaling to B1. Again, what is my reason behind it? S1 is equaling to B1. What will be our reason behind it?
Angles in the same segment.
So you have angles in...
Actually, like...
Yeah, you have angles in the same seg. Yes, okay. You're fine.
Yes.
Okay. And then we also know, the other thing that we also know is this one. We'll start with the things that we know for sure. We know that A2 is equivalent to what?
A2.
Yes.
What's A2 actually?
Yes,
Oh, A2.
Yes, A2. Can you see A2? Who's creating A2? Let's look at who's creating A2.
Yeah.
A2 is subtended by what?
By OB.
By OB, ne? Is there any other angle subtended by OB?
Yes, S2.
Okay. Is what?
S2.
S2, ne? Okay, so you'll say to me, okay, you can safely say that A2 is equaling to S2. And then what would be your reason behind this one, Jen?
Angles in the same seg.
So you have angles again in same seg, okay? We're still moving. Now, so you just told me which, okay, A is equaling to S2. Okay. And then you also said to me, S1 is equaling to B1. And then you said it's angles in the same segment. But now I want us to look at something else here. Let's look at something else here. If we look at the following here, we can see that we have OB. What is OB? According to you.
Oh, yeah.
What is OB?
It's a...
Any line drawn
Can
from
we
the
say it's
center
a
to a
chord?
circumference.
No, it's a radius, actually.
It's a radius, ne?
It's a radius.
Okay.
Yes.
So this is a radius. And then what do you call OA?
Also a radius.
It's also a radius. Okay, good for us. So this one here, it's a radius. And then this one here, it's also a radius. So it means this one and this one, they are equal. Do you agree with me?
Yes.
Now, if those two are equal, what is it that you can tell me about A2 and B1 then?
A2, they are also equal.
Okay, what will be your reason behind this? Why are these two equal?
What's the reason? I know it's like when there's like two radius, like the line, like in the bottom, like makes like them to be equal. But the reason,
You're
sure.
not sure about the reason. You're not sure about the reason. Okay, the reason that we use for that one, it says angles opposite equal sides.
Equal sides.
Yeah, we have
Yes,
angles
yes.
opposite equal sides. Now look at the following then. Look at the following as we finish. Now, again, we are trying to prove that S1 is equivalent to S2 again. But now look at the following. S1 is equivalent to B1. Can you see that?
Yes.
And then A2 is equivalent to what?
S2.
A2 is equivalent to what? To S2. Is there anything that you can tell me now?
About?
Like, look at this. Again, we are saying, you see S1 is equivalent to B1 again.
Yes.
Now, A2 is
S2.
equivalent to B1. Is it possible for me to replace this thing? Look at this one. I can replace B1. Instead of writing it as B1, I can write it as 1 because B1 is equivalent to A2. So instead of writing it as B1, I can write it as A2. Do you agree with me?
A2. Yes.
So in other words, what does that mean? It means, therefore, it means S1.
S1 is equals to S2.
Yeah, S1 is going to be equaling to S2. Let's finish that one. So S1 is going to be equivalent to what? To S2. So we managed to prove that one. So S1 is going to be equivalent to
Yes.
S2. If they ask us why are they equal, obvious, we saw that which both of them both are equal to equal angles. Again,
yes.
Both equal to equal angles. So both of them are equaling to equal angles. So we've managed to prove that one also. Are you good?
Yes.
Okay, so we're going to the last one now. We are going to the last one. Last one, it says OB, it is a tangent to a circle with CBS. So I'll just try to erase everything. But the good thing is this, Ben, when you go to the next question, even if you couldn't prove with S1 is equaling to S2, when you go to the next question, this angle here, you can name them. Like if they didn't say anything, you can say this one here is Y, this one here is Y. It's true when you go to the next question. That's the nicest thing about these questions of proving that even if I cannot prove when I go to the next question, whatever statement that I was supposed to prove here, when I go to the next question, the statement is true. So now, when I go to this question here, I know that S1 is equaling to S2. Let's try to erase some of these things here. We know that here we have a circle. And then now we need to have OB. Look at OB here. So I'm just going to erase the radius because we need OB. So we need this one here as OB. So I will say here we have OB. And then they're saying we should prove that OB is a tangent to CBS. So let's go and draw that one. So we have OB, which should be a tangent to C, and then it goes to B, and then it goes to S, something like this. Ne? Yeah, so you're supposed to have a circle like this. So in other words, Ben, what they're trying to tell you here, they're trying to tell you which you have a chord CB. That's what you should be looking for. You should be looking for a chord CB. So you have a chord CB. So CB becomes our chord. And then OB becomes our tangent. So now we are going to have an angle between a tangent and a chord. So what we are supposed to prove, Tim, we'll write it here. We are required to prove, let me erase this one because we've already proven it. What we are required to prove is that B1 RTP. We are required to prove that B1 is equaling to, let's look at the angle subtended by BC. Which angle is going to be subtended by BC? If we take the blue circle,
It's S2.
it's S2. Ne? So if we can prove that B1 is equaling to S2, then we are done.
Yes.
Now let's check from the previous question that we did. Look at the following. From the previous question that we did. From the previous question that we did, we said S1 is equaling to B1, if you remember correctly. Here.
Yes. Yes.
This was B1
S1
here.
is equal to B1. Yes.
S1 was equaling to B1 again. And then we also said A2 is equaling to what? To S2 again. But
yes.
A2 was equaling to B1, meaning that, in other words, it is true that B1 is also going to be equaling to S2. These two are also going to be equal because both of them are equaling to A2. Can you see that one again?
Yes.
So when we do this one, so I'll write it here. So we have 11.3. How do I prove which this thing is a tangent? I am going to say to them, okay, first thing first, B1 is equaling to S2. And then my reason here is that both are equaling to A2. Or if you don't want to say this, you can say that you've proven this thing. It has already been proven in the previous question here, if you remember correctly. And then therefore it makes OB to be a tangent. It makes OB to be a tangent. And then it's going to be a tangent. What is our reason? How did we prove this? We proved this using the tan chord theorem again. But now we're going to say the converse of a tan chord theorem. Does it make sense then?